Hello everyone, welcome with the fourth video with the fourth problem. The depth of a well up to a water surface in it is h meter. A stone is dropped into the well from the ground. After 3 seconds, the second sound of splash is heard at the ground. If the velocity of sound is 330 meter per second, find the value of h. With the statement, we have drawn this diagram where this is the ground surface, and from the ground surface till the water level the distance is h. A stone is dropped, as the statement says. The stone is dropped. So if the stone is dropped, for stone, what will be the condition? For stone, initial velocity will be 0. At the same time, the s will be minus times of h as it is traveling down. The time taken to reach the stone till the water level is your t1. Okay. At the same time, the sound is reaching to the observer ear after some time. So we'll take a condition for sound. For sound, as you already know that the velocity of a sound is constant. So here velocity of a sound will be 330 meter per second, which is actually a constant term. Here the distance covered will be h. As it is covering a distance in upward direction, it will be positive h. Now talking about the time. Now here it is bit careful about the time, how it is. Question says that after 3 seconds. After 3 seconds means what? When the stone was dropped, after dropping the stone, after that 3 seconds, the sound of a splash is heard. Means what? Starting from here, when the stone was dropped, at that time the whole time is traveled, and then this time is traveled, and then when it has reached here, it has reached after 3 seconds. So stone is reaching here with a time t1, and here the sound is reaching till the observer's ear. So from here till here the time is 3 seconds. So for this t, it will be 3 minus t1. I hope you understood. From here till here it is 3. So if this is subtracted, then this will be remaining, and that is the time t for the sound. Now we apply the kinematical equation for the stone. So kinematical equation for the stone, s is equals to ut minus of half gt square. In this h will be your minus h, u will be 0, half g will be 9.81, and t will be t1 square. With that, minus sign will be deducted. H will be 4.905 t1 square. Let's take this equation as equation A. Similarly, we'll go for the sound. So as it is having a velocity constant, so it will not use kinematical equation, but it will be using simply displacement or a distance is equals to velocity or a speed into time. So here s is your h, u is your 330, which is the velocity. So there is no u, no v, it's a simply a velocity into the time t. Time t here it is 3 minus t1, which gives h is equals to 330 bracket 3 minus t1. This is equation B. If you'll see here, the equation A and equation B has one common term, which is your h. So if we'll see here, from A and B, 4.905 t1 square can be equal to 330 3 minus t1, which can also be written as 4.905 t1 square equals to 990 minus 330 t1. If we solve this kinematically, if we solve it in the form of a simultaneous equation, then t1 will be your 2.876 second. At the same time, if I want to find out h, I can substitute in equation A or equation B, and you can find out value of h. So substitute t1 in equation, let's take A. So h is equals to 4.905 t1 square. We'll substitute t1 value in this, and then we can get 40.57 meter. With this, I hope that you understood the problem solution. Thank you.